Hello, everybody. So today we're going to start chapter 4, or sorry, this week we're going to start chapter 4, which deals with fractions. And as you notice on your syllabus, this is going to be separated into like a couple weeks because fractions normally give students the most trouble. However, if you are just organized and you keep things nice and neat, you shouldn't have too many issues with it. It's just a matter of, just like I said, just keeping everything organized and understanding what's happening. So first, let's go ahead and define what a fraction is. So a fraction is written as a over b, where a and b are integers and b is not allowed to equal 0. Okay? So if I just kind of blow up the fraction and write it again, there are names. The top of the fraction is called the numerator. And then the bottom of the fraction is called the denominator. All right. And visually, we can represent fractions like the fraction 1/3. Visually, that would look something like this. So I can have like a circle split up into 3 pieces. And one of the pieces would be shaded. So another way that we can kind of identify fractions would be the top part would be like the part, or in this case, the part shaded. And then your denominator, the bottom, would be the whole thing. So like how many pieces total. So as you can see here with this demonstration, 1/3 I can represent as, in a circle, 3 parts, only one of them is shaded. Another way I could have done this is just by drawing a rectangle here. Notice there are 3 total pieces to the rectangle. However, I shaded one of them. So that's going to be 1/3. Now, there is one property that I want to go over, and it's called the property of 1. All right. And this property of 1 basically says this. Any number except 0 divided by itself is 1. Okay? So what does that look like in terms of a fraction? Well, a over a will always equal 1, provided a does not equal 0. Okay? So 3 over 3 equals 1. And if we think about this in terms of a picture, here I have a circle and 3 total spots, or 3 total pieces, so that's my denominator. However, my numerator says, go ahead and shade 3 pieces. So notice I shade the entire circle, or one whole of the circle, okay? Now, there are 3 ways that we can represent fractions. So we'll say 3 ways to write fractions. All right, and the first way is what we call a proper fraction, okay? So a proper fraction looks like this. We're going to use 1/3 again. And what makes this a proper fraction is that our numerator is smaller than the denominator. Okay? So that's what makes this a proper fraction. All right? Now, the second way, or the second type of fraction we have, is an improper fraction. So an example of that would be something like 5 over 3. So here, I think you could see that in this case, the numerator, let me just write numerator again, that looks bad. The numerator is larger than the denominator. Okay? And then the third type of fraction we have is what we call a mixed number, or sometimes you might hear it referred to as a mixed fraction. Okay? Now, in this situation, we're going to have a whole number plus a proper fraction. So an example of that would be like 3 1/2, or -2 2/3. Okay, notice you have the whole number, and then you have that proper fraction attached to it. All right? So what I'm going to do is I'm going to go ahead and draw each one of these just to show you what it looks like, okay? So 1/3, we already know what that looks like, so I'll draw it real fast. All right, there's 1/3. Now, 5/3, notice that if I draw a rectangle, and you could use a circle, but in this case I'm going to do a rectangle. But notice if I do a rectangle, and I shade in 3 pieces, I still need to shade in 2 more pieces, because I have a total of 5. So what I'm going to do is draw another rectangle, separate it, and then shade 2 more pieces. So that is the visual representation of 5/3. Okay? Now the mixed number, and I'm going to do 3 1/2. I'll do circles this time. So notice we have a whole number of 3, which means I have 3 circles that are completely shaded. And then, for the last one, I'm only going to shade half of it. So here's 3 1/2, okay? Now, there is a relationship between the improper fraction. So there is a relationship between the improper fraction and the mixed number. Because if you look at like the pictures, notice, and I'm going to shade for us, notice in the improper fraction example, I have like one whole rectangle shade. Although it's broken up into 3 pieces, they're all shaded. And I kind of have the same exact thing for the mixed number. Notice that I have 1, 2, and 3 completely shaded circles. So you should be thinking, oh, well, maybe there's a relationship between the two. And there is. So what I'm going to show you right now is how to convert between improper fractions and numbers. Or sorry, mixed numbers. So how to convert improper fractions to mixed numbers. Okay? So we're starting off with an improper fraction. Let's say 5/3, and we want to know what does that look like as a mixed number. Well, the key to doing this, honestly, just divide. Just divide the numbers, that's it. So when we look at 5/3, okay, remember the numerator, I'm going to start using that term a lot now. The numerator is going to be the dividend, just like in chapter 1. The 3, your denominator, is your divisor. So when you set this up using long division, the 3 goes outside, the 5 goes inside. 3 goes into 5 one time. 5 minus 3 is 2. Now, normally what we would write here is 1 remainder 2. That was chapter 1. But now that we're learning about fractions, we can actually write the proper answer for this. So the quotient is going to be our whole number. Okay? The remainder is our numerator. And then the divisor out front is our denominator. So 5/3, the improper fraction, is equal to 1 2/3 as a mixed number. So the key to converting from improper to a mixed number is division. That's it. All you got to do is divide. Okay? So now I'm going to show you how to do this the opposite way now. I'm going to show you how to take a mixed fraction or a mixed number and convert to an improper fraction. Now, what's really going to help us out here with this, okay, is we're just going to use a little formula, okay? Just a little formula. So, remember, we're going from a mixed number to an improper fraction. So, here's my mixed number here. So, we're going to do 5 and 2/7, all right? And the way to do this is just follow this formula here. So, your denominator stays the same. That's not going to change. Then in your numerator, here's what you got to do. We're going to take the whole number, and we're going to multiply that by the numerator. Oh, sorry. No, don't write that down. We're going to multiply that by the denominator. Sorry about that. I'm glad I caught myself. And then we're going to add the numerator to it. All right, so once again, denominator stays the same. And then up top, you're gonna take the whole number times the denominator and add the numerator. So an example of this would be the one we have here. So my denominator stays the same. It's going to be a 7. But now I'm going to take 5 times 7 and then add 2. So 5 times 7 is 35. And 35 plus 2 is 37 over 7. And what's nice is you could check yourself. Take the improper fraction and just divide. So let's see what happens. So this is our check, just to make sure we're correct. 7 goes into 37 5 times. And then 37 minus 35 is 2. So notice here, there's your whole number. Sorry, my dog is barking. The remainder is going to be the numerator. And then our denominator stays the same. So we know those two are correct. The last thing I want to do, which we're going to use a lot of this later on, is finding equivalent fractions. Sorry, my dog's barking. I have a puppy. He's about 9 months old. If you're interested and you want a picture, I can always send you a little picture of Arthur. That's his name. He's just a big moose right now. He's the nicest dog ever. But he doesn't know how to find equivalent fractions. So I'm going to teach you and Arthur how to do this. So when we're talking about equivalent fractions, what we're really saying is we want to take a fraction like 2/5, okay? And what we want to do is we want to multiply this fraction by the number 1. Okay? Because remember, 1 times anything is itself. Like 5 times 1 is 5. 10 times 1 is 10. -3 times 1 is still -3. Notice that they're equivalent, meaning that the left and the right-hand sides of this equation, 5 times 1 is 5, 10 times 1 is 10, and -3 times 1 equals -3, are all equal to each other. They're all equivalent. Left and right are the same. But here's the thing. When you're dealing with a fraction, you have a numerator and denominator. So in order for us to build an equivalent fraction, well, we need to multiply by number 1, but we're going to be very clever on how we do. So I don't know why I can't write here. Let's be very clever. Sorry about the glitch. I'm trying to get my dog to calm down, and I'm trying to do 2 things at once. So, earlier in the lecture, we went over this property, which was a over a equals 1, okay? And notice that no matter what, as long as the numerator and denominator are the same exact number, the only number we're not allowed to use is 0, okay? So as long as the number on the top and bottom are the same, what you're really doing is you're multiplying it by 1. So if I look at 2 over 5, well, I can multiply that by 3 over 3. So when we look at this, and this is going to actually bring us into the next section, when we multiply fractions, What we want to do is we always want to simplify first, but we'll worry about that later. The numbers I'm picking here are very small. But all you're going to do is just multiply straight across. So 2 times 3 is 6. 5 times 3 is 15. So what we're saying here, and I'm going to write at the bottom of the screen, what we're saying is 2 over 5 equals 6 over 15. These two fractions are equivalent to each other. And there's an easy way to check that. And many of you may have heard this before. In fact, I know a lot of students have heard this, but a lot of students have no idea when they can apply this. And what we're going to do is we're just going to cross multiply. And what I mean by that is this. To check to see if 2 over 5 and 6 over 15 are equivalent, what we're going to do is we're going to take 2 times 15, and we're going to set that equal to 5 times 6. Now, if the left and the right sides are the same number, then we know they're equivalent fractions. 2 times 15 is 30. 5 times 6 is 30. So they're equivalent fractions. And you can do this, I guess, for as long as you want. You could take 2 over 5 and multiply by any number you want as long as the numerator and the denominator are the same. How about this? How about 10 over 10? Well, 2 times 10 is 20. 5 times 10 is 50. Those are equivalent fractions. How about 2 over 5 times, let's do another one here. How about 11 over 11? Well, that's going to be 22 over 55. They're equivalent fractions. And how do I know they're equivalent fractions? I'm going to highlight. It's because 10 over 10 is really the number 1. And 11 over 11 is really the number 1. Even up here, 3 over 3 is really the number 1. We are just very clever on how we're writing that number 1. And that's going to be it for this section. So I will see you in the next section where we're going to talk about simplifying fractions. And then lastly, we're going to start multiplying fractions.